A transition state is the highest energy, momentary arrangement of atoms that occurs at the top of the energy barrier during a chemical reaction and cannot be isolated but controls how fast the reaction proceeds. Think of a reaction like rolling a ball over a hill from one valley to another. The transition state is the exact moment the ball is at the top of the hill before it rolls down, and it only exists for an instant. Atoms stretch and bend into a strained arrangement in that instant, with bonds halfway broken and halfway formed, which makes it very high in energy. Chemists draw this as a peak on a reaction energy diagram and use its energy to predict how quickly a reaction will happen, because higher peaks mean slower reactions and lower peaks mean faster reactions. We cannot trap or weigh a transition state, but we infer its structure and energy using experiments and computer models. Students often think a transition state is a real, stable molecule you could isolate, but it is not stable or isolable, so avoid imagining it sitting in a bottle. Instead, picture a fleeting shape. Another common mistake is confusing transition state with reaction intermediate, where an intermediate is a real species with a finite lifetime, while a transition state is instantaneous. Remember, intermediates are valleys between peaks, and transition states are the peaks themselves. Some people assume every bond must be completely broken before any new bond forms, but in many reactions, bonds are partially broken and formed at the transition state, so think of partial change rather than all or nothing. For more videos and resources on transition states and reaction mechanisms, check out www.gumballdegree.com.